Yeah, there's a video of a amateur rocket being shot up into space, and you can clearly see a curve, but these guys just always change the subject or ignore it.
That means it will be also on the ground, if you can see from the
whole
rocket.
Bigfoot unicorn shtick.
Yeah, that would be the curvature that we're asking for the measurement of that no one has. That
Okay,
curvature.
but you can see it.
Okay, so why can't you measure it?
So are we trying to disprove flat Earth, or are we trying to prove globe Earth here?
Well, they'd be the same thing.
There's two sides.
In order to disprove the flat Earth, you would need to prove a globe, because.
Okay, so where are the globetards? Are there any globetards in the call?
Yeah, we're just speaking to a few of them.
Okay.
No, the first guy was cool. What is it, Mansky? He's a big-time globe head. He's been coming here for months and just like sideshow Bob walking on rakes 24/7. But the first guy, who is that? Because he could actually hold a conversation. So we've not got someone from the flat Earth side who can pick this up. Who's on? TWN? Setu? DJ?
I am, but I may not be for very long.
Drace?
What I would say is that if that imagery that Mansky's talking about is indicative of a sphere Earth with a radius of 3,959 miles, and when we go to a 20-mile lake, or we look across a 21-mile body of water, we wouldn't see clear to the other side. There would be a horizon at about 2.7 miles and a curvature drop of about 260 feet at the other end. But that's not what we find. So sorry, the imagery.
Can we set aside the curvature drop for a bit? Because I'm presenting here a photo of the Earth, and you're saying that it's been manipulated. Is that correct?
I'm saying that if it is indicative of a sphere Earth with a radius of 3,959 miles or a circumference value of around 25,000 miles, then when we go to a large body of water like a lake and look across 21 miles of surface of water, we wouldn't see clear to the other side. There would be a horizon at 2.7 miles and a curvature drop of 260 feet at the other end. But there isn't.
That's just a statement that you made now.
Yes, correct. So any imagery that's presented to you as some kind of evidence or a claim that it is representative of the Earth as viewed from a very far away, and it comes with those values of this Earth's size, its radius, its diameter, its circumference, then when we go to a large body of water like a lake, and we look across 21 miles of surface of the water, we shouldn't see clear to the other side, but we do. So therefore, do what you will with that imagery. Think about it as you will. If you want to just rest your faith on that unverifiable image, that's on you. Right? But meanwhile,
well, you've got to actually explain the steps.
Yeah, sure.
You can't just tell me that because I'm looking at a circle with some kind of radius that this needs to happen.
Right, so if that is the Earth and its surface is curving, then there's geometric consequences, right, to what we will see and what we can measure on the surface here on Earth, right? Meaning there's a curvature rate to it. So roughly 8 inches per mile squared, which means over a distance of about 20 miles, there would be a curvature drop of around 250 feet. Do you understand?
Right.
How much drop is there? How much drop is there?
I'll go to the Earth curve calculator. We've got, I don't know how to use this in conjunction with the image, whatever.
Because if the Earth doesn't curve as much, that means it would be an even bigger globe.
True. Look, if you're... just looking at the image, if it was, for the sake of argument, not touched at all, right? No Photoshop has been altered. They just took it off, like they printed it as soon as it was taken, right? And nothing happened to it. Would that mean we live on a sphere? If the image was true, mind you.
The correct term, I think, is oblate spheroid, but yeah.
Hypothetically,
So the image,
if it was true, it'd be true.
has been, changed.
If the image was true, the Earth would measure accordingly, curved. However, besides doctoring, there's a very simple explanation, and that they used a wide-angle lens which curves horizontal lines. So if you look at the video, early on when they're close to the ground, does the horizon appear curved? If yes, then this is a wide-angle lens.
I don't know, I don't see a video, and I'm not talking about a specific image. There's lots of images of Earth.
Yeah, and we've gone through you're welcome to try to find one. We've gone through thousands of them, and we have hundreds of ones that don't have a wide-angle lens, and they show flat horizons.
Can you show us that?
According to the math, the ISS is too low to the ground to have the Earth curve, and so they need to use wide-angle lenses to make it appear curved.
Can we all agree that you believe that the image is doctored?
No, I didn't say it was doctored. A lens effect does not mean the image is doctored.
What about an image like without a wide-angle lens?
You have to show me a specific image for me to claim it's doctored or not, okay? It doesn't really matter because the surface determines if the Earth is curved or not. And so if you have an image showing a unicorn in your backyard, and then we go to your backyard and there's no unicorn, I am not obligated to believe in your image. Do you understand?
I can't actually send anything in the chat. I can't send an image.
So you don't understand?
No, I do understand. I'm trying to send an image and I can't.
That may be an issue of just being too new to the server, so you might have to, participate more in chats until you level up, and then they'll grant you that access.
Right. So, do half of you believe that the images are doctored and half of you believe that it's using a wide-angle lens? What is the actual consensus on this? Is there a consensus?
How would there be a consensus on multiple images? Each image is specific to that image. We don't have an imaginary consensus. We're not a cult like the cult you come from. We're not a cult like the cult we left. We're just the people who left your cult, okay? Get it through your brain.
Okay. You can also decide that none of the images are indicative of a globe, that they're either wide-angle lenses or doctored. They're not mutually exclusive. I'll just send DJ the image, whatever.
There's many potential causes for the images. You, like us, can simply...
This is the most standard image.
Images.
I didn't like...
I understand. I'm just saying, any image that contains the globe in it, you can just go test it yourself. Does the reality curve like the image is presenting to you? If it does not, the image is not true, regardless of how it was made.
Right. So, okay. Some images are made with a wide-angle lens, and some are doctored. Can we agree on that at least?
Yeah, sure. NASA admits they like. We have a link here for you from NASA to graphics designer working for NASA who created the blue marble image. They freely admit that they doctor some images and create some images. Many people believe those images are real images. There are other images they claim are real images, and we simply test the surface. So we don't care what other people claim when they don't have any evidence backing those claims. The evidence comes from reality conforming to your images or not. If reality doesn't conform to the image, then the image clearly isn't true regardless of how you derived it. You could have created it through an AI. Whoa! That doesn't mean it was like doctored by a human or using a wide-angle lens. There could be other methods made to create images, like what was he called again? Math Powerland, one of the earlier flat earthers. He claimed to have worked for NASA making paintings, like very realistic paintings of globes, and he ended up making a comedy routine after he stopped working for NASA, and was like, "Is this a painting or a photograph?" And he had globes, and he made fun of this because he was and ended up becoming one of the earlier flat earthers because his paintings were so realistic that people believed they were real pictures of actual globes in outer space. But we're not making claims about the entirety of supposed space pictures. We're testing those claims. The pictures themselves are the claims, and we're testing the claims. Do the claims hold up in reality? And they don't. That's the simple.
I'm not doubting any of that, okay? I'm simply saying, all right, let me put this as cleanly as possible. The images could have been painted, doctored, photoshopped, created pixel by pixel, manually written in a text editor, all right? It doesn't matter. An image as of 2026 has no value whatsoever. It is not proof, all right, alone. But let's say for the sake of argument that an image was not doctored, it was not painted, it's not fake, all right? For the sake of argument, all right? If the image was actually real, taken on a spacecraft outside of Earth, right? If all of those things were true, never mind that you don't believe in them, just say that they were.
Yeah, I'll
The one I
ask you,
posted.
if all of those things, if
I
all of
haven't
those things
finished.
were true, okay, sorry.
All right, if all of those things were true, and you just take any random image like the one I sent you, right, that would indicate that we're on a sphere, right? But I know you don't believe all of this.
No problem, no problem. If we assume all of this is true and we went out into outer space and we saw the Earth as a ball, the Earth would measure as a ball on the surface. It doesn't, so your hypothetical doesn't make any sense.
Right.
And your image doesn't make any sense.
What's wrong with it?
Well, on one half of the ball, you have Africa.
And that's a problem. Why?
Well, on the other side of the ball, you have North and South America, Asia, Europe, Australia, Antarctica, all the oceans and seas surrounding.
So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth and I can get this exact perspective and everything will be fine. In fact, I'll look right now.
Well, then you have the same problem with Google Earth.
WebGL is not supported on my browser. That's great.
Senator, this stuff seems to be going in one of your ears and out the other. Good luck to you, dude.
Hello, guys. How are you guys?
You just told me that my image makes no sense. Out of the
Printer,
blue.
how are you,
Yeah.
bro?
I'm great.
Yeah, it makes
Where are
no
you from,
sense
guys?
because this is not something
Where are you
you
from,
can
guys?
sense. Sorry, I'm
Where are you
responding to
from?
him real quick, and then I guess.
No. Respond to me.
Yes.
Quick.
Yes.
Where are you from?
No. First, I'm responding to him, and then I will respond to you. Don't make me mute you. So it doesn't make any sense because what you experience is a flat, non-rotating world. You see the stars and the sun move in the sky, and you experience the world as a locally flat plane. That's how it's described, that's how it's mathematically used, that's how we function and use the world we live in. However, there's this belief that the world curves beyond what we can experience, and that special people can go outside the globe and experience it as a globe. Meanwhile, you, the plebs, cannot. And so you just have to believe in the superior people, and then you are enlightened because you are part of the religion of the globe. Sorry, we don't buy into that. We actually go out and test their claims, and their claims fall flat.
Unintended. I'm kidding. Yeah, I just realized that I was gonna make a different point, but then I fucked it. I'm sorry, but I don't follow with this whole religion thing, right? With the globe people.
Yeah, it's a globe religion. If you didn't know, the globe religion started as a cult within Pythagoras as a secret doctrine of the Pythagorean cults, and then spread into the mystery schools of Greek, ancient Greek, and our whole current worldview is built on this ancient mystery cult and their secret doctrine. And that's what everybody's been programmed to believe, even though they don't have actually any evidence. All the supposed evidence for it is just logical fallacies, and that's why they removed logic from your curriculum so you didn't understand how you're being manipulated. And then
they removed logic from the curriculum.
Yes,
that's
they essentially
not true.
Essentially removed logic from the curriculum. You only get a primer and slight education on it if you go into philosophy, but even then, it's drowned out by all of the different aspects of philosophy. Back when we had the trivium and the quadrivium, logic and rhetoric were some of the primary things that they taught children, and so they were better equipped to identify logical fallacies. Meanwhile, we get taught Aristophanes, for instance, if Earth is a sphere, shadows would act like this. We see shadows act like this, therefore the Earth is a sphere. This is circular reasoning, but because it's dressed in math, it's dressed in authority, people don't realize.
That's what I've been trying to get at with my whole sphere photo. The point of the sphere photo is not about proving the existence of a sphere from just a photo. It's about getting you to acknowledge that you believe in someone that is oppressing us, controlling us, and feeding us false ideas.
I don't need any belief in that because I can just go out and measure the world and see that someone's not telling me the truth. For I don't know his reasoning for not telling me the truth. Maybe he's just confused. Maybe he's a dumbass. Maybe he inherited this lie from some other guy who might have been malicious. I don't know. I am not them, but I can test the fruits of their labor. I can test if the earth is actually curved or not, because we
You
have
can't
access to
be
the earth.
you can't be making this whole thing about us not being taught logic in school, about a cult created in ancient Greece, about them wanting to control you, and then just go
I
on and
didn't
be
say
like,
them
nope.
wanting to control you. That's you putting words in my mouth.
Well, not you specifically, but it was said in this voice channel earlier.
Yeah, that's because we're not a cult like you. You come from a cult where there's a unified belief that you have to believe. We are an independent group of researchers who all have different opinions and beliefs. However, the only thing we share is the empirical, scientific, and logical necessity of reality. And so
No.
teach each
You do
other.
that.
We teach each other logic. We go through science and physics. That's what we care about. We care about the empiricism, the measurements. If the Earth were measured curved, we would all be globers.
You just can't do that. You can't call me. You can't say that I'm in a cult started in ancient Greece, and then say you're just an independent group of researchers. You can't have it both
Because
ways.
that's just how it is. Because we are not a cult. We don't have a unified belief system like you do. You have one, and you are here policing for your belief system because you have a cognitive dissonance when being faced with the idea that your belief system could be wrong because you were raised in cognitive ease. You were raised with the globe being in all of your programming, all over entertainment, in your education, and you were never presented any alternatives. You were presented this as it was a concrete reality, and so it shaped your ego and your worldview as you think you live on a ball. You think there's outer space and other balls you could go to, and maybe aliens out there, and it creates this whole worldview for you, where you're like random accident of the universe.
If it's so easy to understand, or maybe not to understand, but if it's so observable and measurable and provable that we are on a flat Earth, then why is the consensus different? Why is flat Earth a minority and globe Earth the majority?
Because there's billions of gullible people just like you.
It's actually very easy. In the 1800s, there was a resurgence of flat earthers. In the 1700s, there was a resurgence of flat earthers, and there's always an opposition to this, and that's because the cult, the secret knowledge, the holders of the secret knowledge, we know how the world is, and if it's not how we thought it was, then we were wrong. We were telling everybody things that were wrong, and it's hard to accept that. That's sunken cost fallacy. So there's just human psychological reasons when people get caught up in beliefs. You can see this around any belief, like Scientology or any other thing, where people believe something so hard that they just don't look at reality for what it is. They try to insert their belief into everything, and when it doesn't matches, they just find some excuse to try to make it match. And that's what we keep finding. We wanted to believe the Earth was a ball. None of us wanted to be a flat earther, okay? Most of us who came to this wanted to debunk them. And so we were like, okay, yeah, let's go out and test it. Well, like we'll figure out one way or the other, and just confirm the globe again and again and again until the flat earthers concede. However, what we did was confirm that the Earth isn't a globe over and over again, and eventually we just had to scratch our heads and be like, okay, like who do I talk to? It's far easier to convince people of a lie than to convince people that they've been lied to. And I don't really expect you to believe me or us. I just want you to think about your own beliefs, and then be critical of your own beliefs, and then as you're out and about, and you can look out over the sea or whatever, and you can see, wait, I can see way too far for the globe, and that might cause some interest in science and logic and reasoning, and you might dig into this and figure out that the Earth isn't a ball, but it requires you to find it within yourself the desire to actually search and learn and test these things, because nobody's going to give you all the knowledge. You think the people who want to maintain power would give you all of the knowledge when knowledge itself is power?
See, there you go again, making claims about people holding the power for themselves. Like you just said that. You can't unsay
no, bro, no, this is just basic human psychology. I'm not claiming a grand conspiracy. I'm just saying there are people in this world who have narcissistic tendencies. There are people in this world who have sociopathic tendencies. There are people in this world who are greedy. There are people in this world who are selfish and don't care about humanity. Like, there's many people who do, but the naivety of humanity and most people is to think there's no bad people in the world. There's no bad people who want to keep an advantage over you. And I don't presume to know who those people are. All I know is that I can test the surface, and the surface doesn't match what they told me.
And everybody knows there's corruption in government.
Yeah, my sister says everybody knows there's corruption in government, and we can quote her on that. I mean, it's not hard to imagine that some people are malicious, and I'm not saying that the whole globe idea is a malicious plot. It could be, but it could also just be a massive misunderstanding and people building on that misunderstanding because they believe in the authority and the accolades of the ones before them. They think they're standing on the shoulders of giants.
Or it just could be true.
No, we measured the Earth and it isn't a globe, and so it cannot be true.
Look,
if
the
it's
two
so
main
true,
reasons.
If it's so true, why do you and this printer guy resort to illogical circular reasoning and just wishful thinking?
We don't see it as illogical, wishful thinking. We see it as logical and reasonable.
Okay, give some logic. That's not your. No, dude. Let printer flounder. But he's demonstrating his own illogic. Have you not been listening, Matthew? What has printer? What argument has printer given that's logical?
I'm not. I don't want to like butt in on their.
Okay, well then be quiet.
Let's let them continue. Okay.
No, don't be quiet just because this guy told you to.
It's not logical, Matthew, to say that circular reasoning is logical because you believe in it. That's so far from logic. You are a teacher, bro.
The two main reasons you've given me as to why people... Actually, no, that's a lie. There's a lot of reasons you've given me as to why people don't believe in flat Earth. Is because... Well, I'm just going to list them all. They've been... That's the way they grow up with. That's what's been taught at school. It's cognitive dissonance to change your ideas. It feels bad. You don't want to feel like you're wrong. And that's also what the cult feels. That's why they don't want to change their ideas, because they're also going to feel bad.
What? The first part was all good, but what the cult feels, I don't remember saying... I don't remember personifying a cult. Yeah.
Oh, no, you did say I was in a cult, and you did specify that it started in ancient Greece.
Yeah, I call the globe religion a cult. Yes, that's correct.
And then I asked why the cult hasn't changed its views. You said that they didn't want to feel like they were wrong.
Yeah, that's called the sunken cost fallacy. Like, once you start doing something, you prefer that to have been the right choice rather than the wrong choice. And so humanity generally has this bias where you try to keep up with a broken relationship, even though at the start you should have seen the signs that this was never going to work out. It's just basic psychology.
You know, that's difficult to argue with. To argue that these points are invalid would be really hard because it is hard to change your opinion.
Listen to him rationalize. Crazy.
I don't even blame them. Like, it's tradition. We were raised in this. Like, you see this all around the world with other kinds of traditions. People are raised in this. It's really hard to just let go of your tradition, the thing that you feel like is a part of who you are. It's very familiar, the globe. Like, we were all raised on sci-fi, on the TV. Many of us had rockets and globes in our cribs.
My Cope rationalization is noted.
Yes.
You know, there's a lot of aggression towards globe
Oh,
people.
dude, don't be a snowflake. I don't listen. I pity the fool.
No, come on. You've got to agree.
No, dude, I was once just as brainwashed as you are.
See, you're calling me brainwashed.
Okay, I'm calling myself previously brainwashed. That's what you're not hearing.
No, you said you're just
You're
as
looking
brainwashed
to be
as you
offended
are.
by everything. Don't be offended.
I'm not offended. I'm not actually offended. It's just
okay. Good. Then move on with it.
Yeah. Maybe. Never mind. Forget about that.
So, Printer, shame on us for being.
He's showing you his perspective, like just like I was showing you my perspective. Like, from my perspective, having left the globe belief, I felt like it was like a cult. And now interacting with the people from the globe belief, it feels even more like a cult because of how they react and how triggered they get just by the idea that some of their foundational ideas about how the world is are wrong, because they put so much faith into this whole system.
Yeah, we don't want to stereotype you, right? So we'll try to avoid that. This is what we've gathered from countless conversations and even being introspective ourselves about how we've behaved when we first encountered the information. So we don't want to project that onto you. This is just what we've observed, that the globe belief is devoid of any empirical or logical foundation. And everything that tries to defend it usually is from a place of either anchor bias or, yeah, I don't know, wishful thinking, just a desire to stay on that side for whatever reason. I can't divine anybody's reason for wanting to hold a position that is devoid of empirical evidence or logical consistency.
But they have that illusion of logical consistency or internal consistency within their model. And because they don't understand what a reification fallacy is, they think the model represents reality. And so, because they never were taught deeply logic and how fallacies are so they could identify them, they end up just accepting these things, and especially because it was taught when they were so young, it creates the foundation when they were too young to actually question it. So when you get further in schooling, you're already building on that foundation you assume is true, and if you question it or you don't write the right answers, they fail you on the test, and so it becomes a very programmed machine that pumps out people who believe certain things, and then you find out over time, working in your field, that a lot of the things they taught you in school were outdated, and we're actually moving in this direction now. And so the school creates a certain idea in the general public, even though, like, we get a lot of people in here who think Newton, for instance, still works and is a thing that is believed within physics, when it's a convention that's already been falsified within actual physics. But most people don't know that because they don't go far into physics. They just hear the popularized things on TV or on TV shows and form their opinions based on that.
I mean, look, I'm kind of back here into a dead end because there's really two sides to the flat Earth theory that I'm aware of, and one of them is the experiments, and the other is that that we've been raised wrong, that we've been taught wrong, and all this other stuff. And we can't really seem to agree on any of those. We can't agree on gravity. We can't agree on the drop-off thing, the drop-off distance. I don't even really...
Well, we have no problem agreeing on gravity with many globers. The problem is most globers don't know anything about gravity and don't know that Newton's been debunked, Einstein's been technically debunked, and so they have 79 new theories within the highest levels of academia concerning gravity. There's like 20 different ones that are competing, and are some of them at the highest levels, and some of them are like modified Newtonian dynamics or modified versions of Einsteinian or quantum gravity or holographic gravity. So there's a bunch of different theories right now about what gravity is. But it doesn't change the fact that flat or globe, we all have a downwards vector and things fall. That's just what happens. The effect is the same regardless of your imagined geometry. Gravity has never been a problem. We can even use Newtonian or Einsteinian gravity with flat Earth. All you got to do is change the mass distribution underneath the ground, and it will work the exact same. So the effect is the same regardless of the geometry. The assumed cause has really nothing to do with the geometry.
So there is gravity. Like,
well,
we're not...
yes, there is there's
an effect.
Yeah, there's little g, the effect. We all observe that. Everybody does. There's a problem here with languaging in that people call little g, the effect, gravity, but they also call the cause, big G, gravity. And so when you have the same name for the two different effects or two different things, like, because big G isn't really an effect, it's just an assumption about what causes the effect, because they can't test the assumption. And that's why we end up with so many different theories, because they can't test it.
If I can add to that, Drace, quickly, there's also an issue in the language when it comes to the claim about, oh, it's proven because we've done an experiment to prove it, right? Wherein in this sort of experiment, in this context, what they're calling an experiment, it would basically be a measurement or a test of sorts, whereby, they drop a thing, it's in a vacuum, okay, they measure the density of this thing or calculate it, whatever, compare that with the surrounding medium, and then they drop it, and then they time, the time it takes to fall. They call that an experiment. You know what I mean?
What's wrong with that?
there's nothing wrong with that setup. You're measuring the time it takes from point A to point B. Perfect. You have all your things sorted out. You have your control variables and shit like that. The height, the density gradient, not gradients, differential, et cetera. Right.
The confusing measurement with experiment.
Right.
Measurements are perfectly valid forms of gathering true knowledge, or because they translated science is now knowledge and not the correct application of the scientific method. So you can call it science within that perspective. However, it's not doing an experiment as much as it's just trying to measure something and control the other variables that could affect the measurements.
Yeah.
Right on. Yeah.
There's also contention.
I was just, if I may, right. He asked, what's the problem? The problem is, again, like I said before, and like Drace started off by saying, there's a problem in the language. If you go around saying, I did an experiment to prove gravity, look, I dropped my phone, there's gravity. Okay. Versus, I did an experiment to, test what causes water to boil. Those are two very distinct, areas of inquiry, number one, but also the setup to actually get a result, right? The results are very different, right? Not to mention the process of achieving that result. So to call them or to label them as being, worthwhile being put under the same umbrella is faulty. But we do it kind of colloquially anyway. Go ahead, Tita.
I mean, they're two different experiments, aren't they? Why?
Oh, then
one's not an experiment.
One is an experiment, one is an observation. So, like, you can observe a measurement and you can measure something and get good information out of that. However, an experiment is something to establish a cause and an effect, or cause to an effect. And so you start with finding an effect in nature, like things fall. And so you presume, like, what's the cause of falling? And you might think, well, if I scratch my head and jump, that makes things fall. Retarded. But that would be your positive hypothesis. And when you try that, and it doesn't make things like fall that didn't fall before, then you realize, well, I proved the null hypothesis. I proved that my presumed cause wasn't true. I was just imagining some garbage, and it had nothing to do with what was happening. And that's why the scientific method is so valuable, because you presume the cause, and then you manipulate that presumed cause to see if it has an effect. If it has an effect, like in the case with the water boiling, you heat the water and it starts to boil, you have proven that heat causes water to boil. But when you just measured something falling, you did not prove the cause of that thing falling at all. You just measured something fell. And then if you then take that measurement of the thing falling and then make a bunch of assumptions and mathematics and create a whole model, you can create 79 different models of gravity through different mathematics based on the same effect, but because you never had a cause to test, you can't validate if that cause was the cause of the effect. Does that make sense?
Sorry, I lost you. That was too long. Could you simplify it a little bit? What was your main point?
Let me try. Okay. In one context, you're literally manipulating a thing that you are supposing is causing the other thing to happen. Right?
All right.
Right? You literally manipulate the temperature, keep the pressure constant, whatever, and you see that eventually the water boils. Okay?
Okay.
In the other.
Right? And in the other, you're not manipulating shit. You're just dropping something.
Just observing the effect.
Yeah, and you're measuring how long it takes. You're not manipulating the thing that is supposed to be pulling the thing down. to see if it actually pulls it down or changes.
How would I
Which
do it
also, just
correctly?
quickly, that leads to an assumption that this, whatever the reason for your object falling, has an influence over all matter, right? But observably, we don't see it influencing gas.
Yeah. So from this, you can extrapolate out and assume a bunch of stuff, and that's where the storytelling starts to come into play, right? So like, whereas if you could, for example, say, okay, the mass of the Earth is pulling the thing down towards it. That's your hypothesis, right? That would be
Okay.
the variable responsible for the effect. If you could, hypothetically, manipulate the cause, i.e. manipulate the mass of the Earth, and witness a variance or a change in the rate at which things fall, right? Let's say, I shrink the Earth, in half, and I witness the acceleration of the thing downwards cuts in half, say, just for example, or I reduce it by 90%, and the rate goes from 9.8 to 0.98, right? Cuts that in 10. Shit like that, right?
But even if you could do that, right, you still haven't. You've just demonstrated that there would be a relationship between an object's size or its density or its mass or whatever, right, versus the density or the mass of some other object, right?
Yeah.
You still haven't really established what that interaction is exactly, because Einstein came along and said, right, without the experiment, well, Newton was wrong. There is no force or field emanating from the matter just because it's matter and grabbing onto other things and influencing each other that way. No, he says there is no interaction between those objects at all if there was no space-time.
Right on.
So
So
he's
in
got
this
a third variable involved now.
Yeah, there's a lot more to it, right? But what I outlined would serve as a good stepping stone in that direction, right? Whereby
shrinking the Earth down.
I'm just giving you a silly example, dude. And the whole point is you can't actually do that.
Exactly. Right? Is there an experiment I can do?
In this context, no. Because supposedly the Earth is responsible for this thing, or the Earth's gravity is responsible for this thing. Well, the mass, I should say, excuse me, which causes the gravity. So there's an assumption that those things are intrinsically linked. Right now, implicit in that assumption in the first is that there is a giant mass, for example, in the heliocentric model, floating in space in the first place. Okay, that's the kind of sneaky motherfucker that you kind of just have to ignore or just absorb and forget about. Okay.
There's an experiment you can do for specific gravity.
Right. Yeah, there's stuff that you can test, dude, in this fashion that we're talking about. This is one such that you can't in this sense. So it's as if, over time, it was recognized that you can't really do that in that sense. So the rules of the game, say, or the rules of the field kind of adjusted or they laxed a bit, So as to allow this, context to be enveloped in this field, and okay, we can't really fully experiment in the way that we know we should, but fuck it, we're just going to do it anyway this way with the rules relaxed and still, qualify it as being science. It's almost as if that's what happened. I don't know. Seems like
they freely admit this at the highest levels of academia. They'll say, you'll ask Neil deGrasse Tyson, what is gravity? And he'll say, I don't know. Because at the highest levels, they're like, we don't actually know what gravity is, but we have a pretty good guess, and we have calculated the effect, so we can model it and do all sorts of things with it. And it's useful, but as to proving the effect, it's super difficult. First of all, like he was trying to describe to you earlier, but at the same time, our current theories of gravity don't actually hook gravity into the small things like the kinetic molecular theory doesn't use gravity. A lot of our basic science on the super small scale just doesn't use gravity. If we were assuming gravity, like all matter would start to collapse in on itself if we were coming from the matter itself. So it's kind of hard to understand, and that's why Einstein came up with his bending and warping of space-time, and because now you have a bending and warping of a conceptual medium, and you can't measure it and you can't test it. All you got is the effects, and so the medium is just meant to conform to the effects, and that's why it works so well. But when it came to like distant galaxies and star clusters, Einstein didn't work anymore because the galaxies were turning too fast and the galaxies appeared too old for the Big Bang, and all sorts of things that made the current cosmology kind of fray at the edges. And so we have a lot of people exploring the fringes of cosmology today. We are just the people who are checking the foundations to the cosmology, and once the foundations shift, the whole thing shifts.
All right, so what I've gathered is that dropping something and measuring it is not a valid experiment. It's not real science.
No, it's not a scientific experiment. That's right.
Yeah, it's not a scientific experiment. It's a valid means of you could measure something dropping, and it could be a valid means of gathering information, which could be considered science.
So what is the actual consensus on gravity? Does it exist or not?
Sorry. Printer, can I ask you something? Are you at all familiar? Are you at all familiar with the scientific method, like formally?
Starts off with making a hypothesis, I think, and do an experiment. There's like 7 steps. I can't really remember them now.
Okay. So you, I guess you learned it a little bit in high school. Did a couple things and then had to stop because you changed fields or something.
I'll Google it now. I'll just refresh my memory.
Go for it. And then let's walk through it. Right. If you guys, if I may, you guys, I don't want to interrupt. But I want to ensure that Printer understands why we're saying what we're saying here.
Make an observation, ask a question, form a hypothesis, run an experiment, analyze the data and draw conclusions, share your results, repeat the scientific method.
Right on. Okay, cool. So in the context of you take your phone, you drop it, what do you observe? Or excuse me, you take your phone, you suspend it in the air, and you let go. What do you observe?
I see that it falls.
Okay. Second step.
Why does it fall?
Yeah. So what do you propose is the reason why it fell?
Form a hypothesis. Fell because of gravity.
Okay, cool. Does it go into more detail what the hypothesis consists of?
All right. Fell because all objects. I forgot the name for it. All objects act upon each other with a force at any distance.
I was asking, in that outline that you have there, does it show you the constituent parts of a hypothesis? Maybe research that quickly.
It says form a hypothesis. Wait, I need a
Just Google Google definition of a scientific hypothesis, let's say.
All right. A proposed explanation for a phenomenon. It must be based on observations, and a scientific hypothesis must be based on observations and make a testable and reproducible prediction about reality in the process of beginning with an educated guess or thought.
Perfect. Okay. Does it say anything about the variables? Sorry, guys. I don't
know. I don't see anything.
Okay. Well, basically, your hypothesis, the setup requires your proposed cause for the thing. Okay. And then you have your observation, which is the effect, which depends on which depends on which depends on the supposed cause. So you have your dependent variable, the effect, influenced by the supposed independent variable, the cause, right? That you get to control or manipulate throughout the experiment to see if it affects the result. Okay.
Right.
Independent variable, dependent variable, and then you have a single one or a set of other variables that you want to maintain constant. They call them control variables. That might be influencing this entire thing that you try and, to the best of your abilities, control for. Okay.
Right.
You'll find that online everywhere. You might be botching it a little bit with some terminology here, but you get the gist. Okay.
Okay.
Perfect. So in this setup, with your phone, you observe your phone falling. What would be the independent, dependent, and control variables in the setup?
The independent would be the fall speed, I guess, or fall time, and the control variables would be,
or even the sheer. Sorry, but even just the sheer fact that it falls.
All right, the fact that it falls, its a weight, size, atmospheric pressure around it, elevation, I guess those should be all remain constant.
So the weight you can maintain constant. You can probably do it in a vacuum, so you can maintain the air pressure. Humidity also, because it's in a vacuum. Humidity is 0, right? Et cetera, et cetera, et cetera. Okay.
All right. I don't see a problem until now.
Okay. Now, what about the supposed cause, the independent variable?
Well, that's my hypothesis, isn't it? I'm testing it now.
Everything that we've outlined is defining the hypothesis. Okay. There's one critical thing, right? You already said it. I just want you to see the key into the whole. Okay. Right. What is the cause of the effect? Supposedly.
Supposedly, it's gravity.
Wonderful. So there's your independent variable.
Right.
Experiment. What's your setup? What's your method? What are you going to do?
I am not going to do this right now because I'm going to break my phone.
No, I'm not saying drop your phone, dude. Okay.
Yeah, I'm kidding.
Like outline it, right? You got a plan for this shit, right? Okay, I want to figure this thing out.
All right, I'll drop it from 1 meter. All right, and I'll place a stopwatch next to me, and I'll press start as I drop it. How's that?
No, I'm not saying do it, dude. Okay, but now check this out. Now it seems like you've changed the supposed cause.
Why have I changed it?
Okay, so in the hypothesis, if the supposed cause is gravity, right, the Earth's mass pulling it in for whatever reason, there's bendy warpy space-time, or there's some invisible three-toed gnomes pulling down your phone with lassos or something. Who knows? Whatever. Okay, whatever. If that's the supposed cause, but here you are not necessarily manipulating that supposed cause or that supposed variable, but instead changing the height at which you drop your phone, right? You're basically implying that the height is responsible for the gravity. Because that's all you're changing.
What do you mean I changed it? I didn't change it. It'll be 1 meter the first time. It'll be 1 meter the last time.
Hold on. Wait, let me just, can I bounce in here real quick? Brother, you said that your supposed cause is gravity. So We've got all of our controls. The height is the same. The temperature is the same. The air pressure is the same. Everything is consistent. So now we need to perform an experiment to get the dependent variable to occur. So you have an object, and I don't know what this object is. I don't even know what the observed natural phenomena was in nature, but let's just say we have an object. We're trying to make it fall because the falling is the dependent variable. That is the thing that is observed. So now you have
that was
to
the independent
add,
variable.
No, the dependent variable is the observed effect. It is the effect. The falling of the object is the thing that you saw, correct?
So you disagree with the other dude because he told me that that was the independent variable.
No, he did not.
You misheard.
The dependent variable is the thing that we're trying to cause in the experiment so we can verify our independent variable.
Yeah,
All right, fair enough.
The dependent variable is depends on the independent variable. Right, the effect depends on the cause. Go ahead.
You say gravity is the cause of the thing falling. So now we have all of our controls, we have our object. The next thing you need to do is vary and manipulate the independent variable. In this case, you would have to find an environment that you can add some gravity and take some gravity away to see if adding the gravity makes the thing fall or take away the gravity and it does nothing, right? So, what is gravity and how are you going to manipulate it?
Why would I have to change gravity?
Because that is the thing that you said is going to cause the effect. So you need to add the gravity to get the effect that you're looking for.
I'll go to the ISS and I'll drop it from there.
Holy cow, dude. What are you talking about? Gravity, what is it?
I've answered this question like 50 times already.
Yeah, well, what is
I'll give you my standard response. It's the force that is applied from every object to every other object at any point in the universe.
That's a vague description, and it's just describing something that we don't actually observe.
Did you ask me what gravity is just to disagree on me on it? You already knew what I was going to say.
No, I actually didn't because we get different. Why are you freaking out, bro? I'm being very calm with you. I don't know why you're getting so excited. Do you think you could just take a deep breath? For crying out loud. So, you are describing this is a description of something that, read it off to me again. What is it?
I actually didn't read it from anything.
Oh, so you made it up on the spot. What did you just describe? What is it?
All right, I'll read it off of Google. Gravity is the law that every object with mass attracts every other object in the universe in proportion to each mass and inversely proportional to the square of the distance between them.
Okay, great. So what you need to do is get us whatever that gravity is and put it in this experiment to see if it causes things to fall.
You asked me to change the variable. You didn't ask me to personify gravity and put it in the experiment.
Dude, you're the one that has personified it. You're the one that has given it this vague description, even by Google. So we have to add whatever it is that you think is causing the effect. In this case, what is it, mass? Or is it an attraction of mass? Okay, put that in your experiment, vary that, put it into the experiment, and see if you get the effect that you're looking for.
Yeah, Printer, nobody was asking you to change the variable. What I was highlighting to you is that you implicitly did change the variable simply by changing the height. Because apparently the height is now...
Hold on, wasn't I just told to change gravity in order to verify the experiment?
No, you're not following along very well. What I said is the...
Yeah.
The independent variable is the thing that you would ascribe the causal mechanism to, the thing that makes the other thing fall. You have all your controls. Nothing is changing. We're trying to make the effect, the falling, occur. You said it was gravity. I asked you, what is that? And now you're saying it's some kind of force having to do with mass or something. Okay, well, that force, how can we put that into the scenario to make the effect that we hope will happen? How can you add that to make the effect happen? The dependent variable. How can you make the falling occur? So you're going to put in what? Mass? Or maybe you're going to put in a force? Well, which one is it?
Define put in.
I'm saying apply this to the object that you want to fall.
You want me to apply gravity to my phone?
Yes, that would be your independent variable. That's what you declared.
And what would I apply mean in this context?
That's what I'm asking you, because you actually
you told me to do
know.
it. You have to define it.
Yeah, I'm not the one here that's supposed to define gravity. You are. I don't know what it is. You have described it to me in both your words, and then you gave me Google. So how do we get this into the experiment to make the thing fall?
That's what I'm asking you.
No, I'm asking you. It's your claim.
Well, my claim is that I don't have to apply anything. Gravity is just there.
Oh, so now it's just there. So you're just decided to declare on your own volition that this is why it's happening, even though you can't make it happen in an experiment. That, my friend, is pathetic.
I made a hypothesis, and then I confirmed it using an experiment.
You performed no experiment. You did not apply an independent variable. You said it's always there, and that's why it happens. That's a baseless assertion fallacy, and it's ridiculous.
Yeah, Printer.
If it's not all,
check this out. Okay, this ruffling of the feathers that's going on. Okay, this is you internally starting to recognize the difficulty of this whole thing and why you can't actually do this. As we stated before, okay, you're coming to the recognition that you can't manipulate the supposed cause of the effect. So then you, as you just said, like not 10 seconds ago, you basically just declare it's there anyway. Follow?
How would I, all right, let's say I didn't declare that it was just there. Would I have to change it or not?
If you want to actually explore why the things are falling, you have to come up with a reason, right? A supposed reason, and then demonstrate that supposed reason actually affecting it. Period. It's very, very simple. In this context, obviously you can't, because you can't manipulate gravity hands-on. You can't manipulate the mass of the Earth to demonstrate whether it's going to have an effect on the rate of things falling, or the speed, acceleration, whatever. You can't actually do that. Therefore, it does not qualify as being scientifically experimented on. Period.
So I do have to manipulate it in order for it to qualify.
That's the whole point, dude.
Well, I asked just a few seconds ago if I have to change it.
If you want to change the entire, hold on. Change as in alter the value, like manipulate the variable itself, or do you mean basically change the entire experiment, swap in a different supposed cause from this one? What do you mean?
Change the value.
Change the value. Yes, you have to do that.
I have to either come up with a different cause or change the value of gravity.
Yeah, you can suppose anything as being the proper reason, so long as you can manipulate it and demonstrate that it does or does not have the effect. So you can outlaw if you suppose something, you demonstrate that it doesn't have the effect, then it rules out that this is the cause, and then nobody else has to bother checking it again if they don't want to. Right? So there's value in null hypotheses, dude. Right? But you actually have to have the test, or the experiment, I should say. It has to be a valid experiment, where you actually do manipulate the variable. In this case, you just can't in the first place, as you are coming to grips with reality about it. You can't in this case. So it doesn't qualify.
Well, if not gravity, then what is the effect? What is the cause? Sorry.
Fantastic question. And guess what? Everybody's wondering the same fucking thing.
I have been wondering since the start of this voice chat.
Mm-hmm. But you also came in storming that, oh, you know it's the Earth pulling shit down because of the maths. Right? So you either don't know and are wondering, or are certain and not wondering because you're already certain, or you're in the middle somewhere, or you think it might be this because, I don't know, you're biased in that direction. You were told that ever since you were a kid. I mean, we all were, right? It's not an attack on you personally, right? But these are the facts, man. It's an open question. Even as Drace mentioned before, I think. Neil deGrasse Tyson said the same thing. We don't know. Next question.
Wait, so you don't know either?
Of course not. How the hell would I know?
No one in this voice channel knows why the phone is falling.
Homie, did you not listen to Drace 10 minutes ago? Outlining that there are currently up, what was it, 70? In the 70s, okay, number of different competing extensions or whatever to Einstein's theory.
So that, all right, well, that clears up your position. That's really all I wanted to know.
That we don't know? I'm surprised that hasn't
no,
been...
I wanted...
Yeah, I'm surprised that hasn't...
to clear up your position.
Yeah, and we're not making claims about that. We're just trying to show you that the people who come in here storming that they do know don't actually know. But they say it anyway. And then we inquire about these details, and they're like, they don't know. So their arrogance, slowly subsides, and they're like, okay. Sometimes they just leave and come back and argue the same points again and again and again, But at least, it seems like you're coming to this realization, which is good. Now, if we're wrong, okay, I'll caveat all this with this. So if I'm wrong on this, and we're all wrong on this, okay, I want to know. Okay? So come back if you find something.
That is not what I already stated. That's not gravity.
What?
Sorry, what?
Well, you said come back when you find something, and it's clear that the something that I've tried to tell you that it is, you haven't accepted, so I need to find something else.
Yeah. I get that. Yeah, if you come across something, right, something novel or whatever, feel free to bring it to the panel.
Now, the biggest problem that you're going to be bucking up against is that there is no exclusive downward vector for all matter. So these are more circumstantial observations than they are anything else. If you take an object and you put it in a medium, it may go downward. If you put it in another medium, it may go upward. This is what we observe, but we cannot actually give you concretely a cause as to why these things happen. They just do. It's almost like a law. We just observe it. We can't really explain why. This is just what happens.
You're talking about water now, right?
I'm talking about any medium. So you can take an anvil. It will fall downward in both air and water. But then if you put it in mercury, which is a liquid state of metal, then it will float in mercury. It will go upward.
What's your position on buoyancy?
Buoyancy is something that we observe, but the term buoyancy actually begs the question of gravity. What we do observe is specific gravity, which is objects in mediums where they are less dense go upward, and when they are more dense, they go downward. That's what we observe.
I mean, that's true. So why not? All right, never mind. Well, I still have more questions. For example, why Do you believe in this dome?
There's no belief in the dome. The evidence for any kind of container, we don't say dome, but a container for the gas pressure is required to have the gas pressure in the first place. Now, you say somebody here told you about a dome. Who was that?
That was you.
I didn't say anything about a dome.
I mean the container. I called it a dome.
Okay. So there's a container for the gas pressure that we have on Earth. This is not disputable. We have gas pressure. The requirement for gas pressure in physics is containment.
Does it go under the flat Earth as well?
What do you mean under?
I mean, if, let's say, the container was like obeloid thing or whatever, is there no up and down of the flat Earth? What? I'm not getting.
Well, as far as we can tell, the Earth itself is horizontally oriented. That's how we experience it. Up and down is the same for everybody. So it is a horizontal plane. What its complete construction is, I have no idea. I have no idea what the entire, realm looks like overall. But if we have gas pressure, then it must be contained.
Have gas pressure. Why is he asking about buoyancy now when it was addressed a long time ago? I don't remember why. Properties that are relevant. Okay. The dome exists because of gas. I'm going to Google gas pressure. It's caused by the force.
First of all,
by gas molecules colliding with the surfaces of objects. Although the force of each collision is very small, these refer. Okay. You were going to say something?
No, I mean, if you're going to call it a dome, that's fine. I don't know if it's a dome. There's a containment.
You don't know what shape it is?
I have no idea. What would that matter? We have the gas pressure. It could be a cake top for all I know. I don't know.
But it can't be a cube if the...
Bro, the thing is, we don't have a replacement cosmology for you. We are not a different belief system to believe in. So we just have measurements and evidence and logic that proves the old belief system false. So we don't have a replacement for you. So you asking us about the edge of the world or how things work that are unknown have no relevance to our actual arguments or points.
I still think it's worth talking about.
Well, fair enough. We would begin to, yeah. If you're going to speculate, we're going to, go ahead.
Yeah, exactly. I wanted to say, if you want to speculate, we have speculation Sundays where people can speculate about why they think this works or that works. And we'll be like, well, how do we prove that? And if there's no way to prove that, nobody's going to believe that. We don't believe things willy-nilly here. We try to be empiricists about things. If we can't measure and prove it, there's no reason for us to even entertain it normally.
The curiosity...
You can't really prove this dome, can you? You can't
we
see
can't.
It, you can't measure it, you can't test it?
Sorry, friend. The dome that you think exists, because you keep using the word dome, the evidence for the dome is the gas pressure. The container itself, the gas pressure is the necessary antecedent, or the container is the necessary antecedent for the gas pressure. You cannot have one without the other.
Yeah, so
but there is a downward force.
Yeah,
No, there
that doesn't
isn't.
affect gas though. That's the problem. If you take gas and you release it, if you take two bulbs and connect them with a valve, you have gas in one bulb and vacuum in the other, and then you open the valve, the gas will expand into the available volume, and it will not be impeded at all by any imagined gravity. And so this is the second law of thermodynamics. This is the most simplest demonstration. I have a recording of Richard Feynman saying that this is the most basic demonstration of the second law of thermodynamics. They claim we live in a vacuum, an ever-expanding vacuum. That means the gas would just continue to expand into the available volume and be gone. And then the next layer and the next layer and the next layer until you have no air on the earth. And then the entire ocean would evaporate. And then you would have no air, no liquids, and everything would die. That's the globe in a nutshell. It's violating natural law, which we can demonstrate here on Earth, where gravity is supposed to be the strongest, and it does not impede gas at all.
The reality is that the story behind the Earth being a ball within this vacuum is that however many billions of years ago, this ball Earth was cooling and off-gassing. So all of that energy, heat, gas that was leaving the surface of this ball would be leaving and filling the available volume of the ever-expanding vacuum, meaning no pressure of any kind would have ever been developed in the first place.
Let's say that I accept the container, all right? No strings. What's around it? Is there matter around it, or is there nothing?
How would we know that?
Yeah, just
choose any one. Is it not one of those two things?
No, this is not multiple choice speculation. You're asking us a question that we cannot confirm. Why would we even speculate on something so silly?
Two things.
No, bro, this is not pick your own cosmology day. We're not just willy-nilly deciding what...
Can you just humor me and do it?
No.
Can we just humor you and make up a new cosmology? We can do whatever we want if we wanted to do that. We have done...
I'm not asking you to make a new cosmology.
That's exactly what you're asking us to do.
There's plenty of...
No, I'm simply asking you to... Sorry.
Yes, you are asking us to make a new cosmology. And there's plenty of flat earthers who have done that. We are not those people. We are empiricists. So making up beliefs and imagining things are true is not what we do. We like to test. If those people can bring to us their imaginations, and we test if those imaginations are true, and if they're not testable, we don't have any reason to believe them.
Yeah, we're not going to create a fantasy.
Wait.
To create
a fantasy.
So you're presenting a false dichotomy. You're giving us two options, neither of which you could even possibly verify.
Yeah.
No, we're not going to engage in false dichotomies with you. Sorry.
I don't see why this is such a big deal. I'm simply asking what's around the container.
Anyways, what is the point? Why would we do this for you? Why are you asking us to speculate about stupid shit?
It's stupid shit.
This is because you didn't learn logic well enough in school. You didn't realize that you were making a false dichotomy, and you're asking us to be illogical. And we don't want to be illogical, so we refuse.
You don't want to imagine what's around the container.
No, this is not a place for us to imagine things. If you want to imagine things, go to one of these, places where people think that they're dogs or cats. Imagine whatever you want. We're not going to engage in that. It's pointless, fruitless, time wasting.
Yeah, anybody can imagine anything outside of the reality. You can imagine there are ponies, there are leprechauns. You can imagine whatever you want. We don't want to imagine anything. Because if you start imagining things and believing in a certain imagination of yours, because, oh, I like this one, Well, that creates a bias. That creates tinted glasses that you now look at reality through, where you try to match reality to your belief. We don't want to become biased like that. We don't want to taint our clear eyes. We want to see the world for what it is and let the world tell us what it is based on what it gives us, not based on our imaginations and trying to match the world to those imaginations.
So there could be anything there. There could be ponies, there could be whatever, we don't know.
We don't know, yes.
That I was not expecting so much backlash from that question.
We get this all the time.
Right, how about this
annoying.
one?
It's annoying
Why
because we
is...
get this all the time. Let me just finish this. We get this all the time where people tell us, what's beyond the end of the earth? And the same idiots are telling us, well, the earth is a globe because air moves around a tree. We're not making claims what's beyond the known earth. We're just making claims about the surface of the earth that anybody can go out and test. And we're not even asking you to believe our claims. We're just saying, maybe you should question your claims and go check them.
So anything outside the earth is off limits. Is that what you're telling me?
Anything outside the earth we don't know. Like, it could be many things. There's if you actually started to research this and look at all the different ideas of the different flat earthers, we're the conservative flat earthers who stick only to the measurements and the empirical and the logic. And so you can't come to us with some retarded idea of how you think the world works without evidence. However, there's millions of flat earthers in the world. And
I didn't even present an idea. I simply asked you what's out there.
Yeah, that's why I'm telling you. There's many of flat earthers in the world who have imagined how the world is beyond the known land masses. And if you look into that, there's many interesting tidbits you find within it. However, you'll notice that they all have a belief they're trying to push, because aspects of what they believe are not verifiable. We like to stay within the verifiable. So you can explore this topic and find what you're looking for, but we're not going to do that for you because we don't do that here.
Right. So, like, you just don't care about anything outside of the earth, like the moon, the sun, the stars, nothing?
Oh, we care about all of that stuff. We just are not delusional enough to think that we know what that is without enough data to determine what it is. And so that means that we can look at all of the different speculations about what it is without having a bias that makes us go like, oh, I'll dismiss this out of hand because it doesn't match my ideas. And so we can look at all of the ideas and be like, well, there's problem here, there's problem there, there's problem over there. But they had some interesting ideas over here, they had some interesting data over there, and so the more data you have, the better idea you can have about the world. But there's always going to be a problem with you don't have enough data, and that's the position we're in right now. We can't make you a map. We can't map the whole world for you. What we can do is measure the ground, and anybody can do that.
So a consensus can only be reached if anyone can perform an experiment on it.
Yeah, essentially, if you can make it so that it's completely logical, you have evidence to support it, and like, yeah, then you can get people to have a consensus on it. Problem with the current consensus is we have a bunch of fallacies, and people have a consensus on the fallacies, and then they appeal to the majority because many people believe the fallacies. That's just stacking fallacies, and we don't do that here. We like to stay empirical, give us the data, or we'll just ignore the claims, because the claims without evidence can be dismissed without evidence.
But it is true that everyone has to be able to perform the experiment, right? Within reason.
Essentially, yeah, that's basic empiricism. That's repeatability. If you can't repeat the experiment, if it's something that you have this special fairy dust that allows you to talk to the fairies, and that's how you know all this stuff, and we just have to accept it because you have the special fairy dust, and we're not allowed to get any special fairy dust, then that's not acceptable.
So, if I was a millionaire and had access to a special hot air balloon that allowed me to go above 70 kilometers, let's say, and I just kept going up, and I reached the container, and I made some measurements about it, and I came back down and told everyone, that wouldn't be enough because no one else can do this. I'm the special fairy that can tell people whatever I want.
Yeah, you claim you have this special technology. Of course, that's a pretty absurd example. With
hot air
balloon, because we have sent up all sorts of balloons of all sorts of types, and we know how high they can go and where they stop. So it's not reaching any imagined dome yet, because we can't get high enough. We just have not been able to go high enough. They claim the ISS, for instance, is circling the Earth, and we get these pictures, and we see this Earth curve in the pictures. But if you look at the math, the ISS is so close to the surface, it only sees about 3% of the surface. And so it has a horizon line, just like you and me, that's circular around the craft if it were at that height. And I don't know that it is at that height. That's just the height they tell us it's at.
So where is it then?
I don't know. I didn't put it up there. I can't verify its position.
But it is somewhere high up.
No, not sure how high it is, if it even is there, because there's many different ways of spoofing its position. So you could see something in the air and you think it's the ISS, but it could be many different things, and we have no way of determining which of those things it actually is, if it is. So usually
I find this problematic because not everyone can perform experiments. Not everyone can perform every experiment, especially the expensive ones.
Oh, I agree. It's not reasonable for you to expect someone to perform every experiment for every single thing. You can watch many experiments if you want to understand something. You don't have to perform all of them yourself. You can watch other people perform them, and then. But if you're gonna try to build on that or make claims on that, then your experiments, you would need to do experiments to validate that. Like I am writing a optical framework, for instance, a scientific paper essentially, and before I publish it, even though I have a bunch of data collected over the years from other sources, I'm gonna make my own data to go with all the other data before I publish it.
Even though you have your own data, you're gonna make your own data to go with the other data before you publish it. How is that helping anything? You can't, that's not allowing me to do the experiment for myself.
For instance, the optical framework, when you create something like that, what you want to do is, and that's what I did, is you make it falsifiable. And so people can go out if they want, try to replicate your findings, and if the findings don't come out that way, then you have falsified the framework. And most scientists and most people don't allow for this and don't give this opportunity because they are scared of their funding. They are dependent on this. I am not. And so I don't care if I'm wrong. If I'm wrong and somebody proves me wrong, I'm happy because I learned something new. Just like I went into this flat earth thing, I wanted to prove them wrong, but because they showed me that I was wrong in my assumptions, I was like, okay, I'll test this other thing because I'm not going to believe you. I don't believe anybody. The world informs me of what I believe, and so I'm not subject to the manipulations of other people.
You said that they can falsify you if they want. How are they going to do that?
It's very easy. For instance, when it comes to the globe, they tell you that the horizon should be X far away based on the geometry. And then once optics got more advanced and we started seeing far smaller things with larger optics and zoom capabilities, we suddenly started realizing we were seeing 10 times beyond the proposed Earth curvature, which we assumed was the geometric limit or the horizon. And so after that, they started saying, oh, well, the horizon's apparent. Well, there must be refraction causing the light to bend around the globe and making it appear flat in all observations up to the horizon. And then beyond the horizon, that's where it starts to curve, boys. It's somewhere we can't detect. That's where we start to see the curve. But it always looks flat up to the horizon. And we can see way too far, so it must be refraction. Problem is, they never actually tested that, and they just kept on assuming that the light was, whenever the observation didn't match their presumption of the globe, they would just bend the light to make it match. And so it became an ad hoc excuse to save them. And so I proposed a simple test, because visible light refracts at a certain rate. Infrared light refracts at a lesser rate. And so the two wavelengths don't refract at the same rate. And so you can take two cameras, one calibrated for infrared, one calibrated for visible light, and then you can observe the horizon with those two cameras. And in the visible light camera, the globe predicts that you would see further in visible light because the light is bending around the globe, making it appear flat so you can see so far. However, infrared doesn't refract as much as visible light, so it wouldn't bend as much, wouldn't allow you to see as far. So you have a prediction for the globe. You see further in visible light, less far in infrared. And then for us, we don't need Earth curvature for anything. In my optical framework, I describe every single refractive effect over a flat surface. It's very simple and very easy. So for us, infrared refracts less, so it causes less ray loss. So when the bottom rays of objects in the distance get refracted down, if those rays hit the ground, you're not going to recover those rays, and so the bottom of the object will be occluded or will be obscured. That's just the light hitting your eye.
Right. So you need two cameras for this setup. Or
yeah, that's to falsify my framework, and because what I've seen through a bunch of other people using infrared cameras and people taking pictures, is once we use infrared, we actually see further because infrared cuts through the haze and allows us to see further, and it doesn't refract as much, so we have less ray loss. And so that's the inverse prediction if the Earth is flat, is that we would see further with infrared, less far with visible, which is completely the opposite of the globe. And all of the data I've seen so far seems to support the flat Earth position, or that we see further with infrared, and that's why all of the world record long distance photographs are all taken in infrared.
Right. Well, here's my problem with this take on experimentation. It's that you don't trust isolated experiments that can't be replicated. And that sounds like common sense, like why would I trust that? But let's say that you were the one performing the experiment. And the experiment was you go build some device and you go really high up and you find the container, right? And you see it, or you don't see it with your very own eyes. Maybe it's not, maybe it's made of something like, I don't know, that you can't see. Then you come back down and you try to publish your findings, but no one else can do this. No one else can build this experiment, and no one else can falsify it unless they have giant wads of cash just lying around.
Yeah, but I don't have giant wads of cash. This doesn't require giant wads of cash.
Your experiment doesn't.
No,
but
you're inverting it, because the Globers claim that you require giant wads of cash to get things into low Earth orbit, and even Werner von Braun and Elon Musk claim that to get to the moon would require multiple rockets to refuel in orbit, which didn't happen with the moon landings, for example. So it's clear that that was a lie, because they didn't have the fuel to get to the moon, according to the space experts.
Moon landing costed billions of dollars, though.
Did it?
A free experiment.
Yeah, and who got all that money?
It was used to build the rocket. And it was financed by the American government. Am I wrong there? Anyway, that's besides the point. My point is that if someone actually did go up and touch the container, no one would believe them because they can't replicate the experiment.
Well, they should be able to replicate the experiment if someone can go and do that.
Why? They don't have the capacity to. They don't have the money.
How did they do that? How
With
did
a
they
lot of
do
money.
that? What technology did they use to do that?
They used a hot air balloon. Or alternatively, a rocket.
So, like, why isn't other people testing it? And, like, if
anyone can make a hot air balloon
result, we need to figure out why he's getting a different result from everybody else doing it.
I didn't even imply that they.
This is kind of like with the flat Earth. Everybody else is doing it, and they're finding the Earth is flat. Meanwhile, there's this one guy who claims that he has done it with the same equipment that like everybody else is using, but somehow he found it.
I'm trying to. You're not really getting my point. I'm trying to put you in. I'm trying to make you put yourself in the perspective of someone that actually goes and does this. That actually builds a rocket and touches the container. And then comes back down and no one believes him because they can't also build a rocket. And I'm trying to get you to see that there's a problem with that. You can't expect all experiments to be replicated by anyone.
No, I agree with you. There's a giant problem with that. someone claiming to have done that, and then claiming that when he did that, he debunked observable reality, that's a problem. Why would you believe that?
Debunked. What do you mean debunked observable reality?
Because the guy who, in your example, the dome in your example is the globe Earth. In the globe Earth, they claim they have so much money.
No, it's not the globe Earth. It's the container.
Space. No, bro, it's the same analogy. The analogy is the same. In your example, the container is the globe Earth. They claim
It's
they have the power and the money to go and verify the container, the globe Earth, but nobody else can go do that. And then when we go actually and test the ground, which should be curved like they claim, because they have the secret knowledge, it isn't curved. So we know that they are not telling us the whole truth.
I'm sorry, am I wrong that you claim that there is a container that causes gas pressure around the Earth?
There is containment of the gas. We don't know how that containment works.
Okay, so let's say someone wanted to try and find out. So they build a rocket and they go up.
Yeah.
Right.
They go up and
they either see it or see something
else. They can't
else.
go any further, and then what?
And then they come back down.
Yeah,
and try to tell
went
people
up,
about
they
it.
couldn't get any further. They didn't find the end. So how did that help?
What do you mean they couldn't get any further? You yourself said you don't know what's up there. Why are you assuming now that they couldn't get any further? What does that even mean?
Because that's how rockets work. Rockets push off things.
Okay. I don't think you're getting my point here.
I get your point. You're imagining that what if
what is my
went
point?
Up into the, you're imagining what if somebody went up to the sky and touched the imagined end point, and then went down and told everybody, well, I have the secret knowledge of the end point of the sky, and nobody believed him.
Yeah.
Yeah?
Okay.
Where are you going with that?
I'm saying they should believe him.
Why? Because one retarded guy who was hallucinating on shrooms and believed he did all those things, claimed he did those things. Why should we fucking believe him? That's called being naive and gullible, buddy.
Well, relax.
You need to actually test his claims. If he claims that you can go up there and you can do this in a hot air balloon, and people go up there and they can't, then you know he is bullshitting you. Just like we go out and they claim the earth is curved and we go out and test it, we know they're bullshitting us.
Nothing that has been said up to this point has pointed me to think that you can't go and touch the container. What's stopping you from going higher?
Rockets push off things. So, like, if you take a rocket and make it push all of its exhaust into a completely vacuous chamber, the vacuous chamber will fill, and it's not until the gas hits the wall of the container that the rocket moves forward.
No, that's not true.
Oh, we have evidence of that.
No, you don't. That's wrong.
Oh, we have.
I'm sorry, but when you throw something, you're gonna get immediately pushed back before that thing hits any wall. You can try this with yourself now by throwing a bottle.
Are you in a medium?
Yes, I'm in air.
Yeah.
That doesn't disprove anything.
Oh, you're pushing against the air.
All right, and so is the rocket.
Yeah, you're claiming the rocket's in nowhere.
No, I never made that claim. I simply said that rockets can go up.
Yeah, and eventually the air gets so thin that they don't work very well. And so there's different types of nozzles and different things they do to try to make them work better and go higher. And that's why you have ballistic intercontinental missiles. However, there's a limit. You can't go pushing off nothing.
You can. It's Newton's third or first, I don't remember, law of motion. I can't prove it because I'm on Earth. To prove it, I would have to go to space.
Yeah, unfalsifiable nonsense.
No, it's not unfalsifiable by you. You're saying that it only happens because I'm in a medium.
You could not prove it. That means it's unfalsifiable. You cannot.
I can't prove it by your standards.
You have to go into Narnia through the magic closet to talk to the lion and tell me he's real.
Wait, what?
All right. Rockets have the same effectiveness no matter where they are, because it doesn't matter that they're pushing against the air. As soon as you throw something, you get an equal and opposite reaction. That's one of Newton's laws of motion.
Yeah.
And that's true. It's measurable. It's detectable.
We've all heard this claim. However, we have not seen any evidence that this is true, that you can push off nothing. And so far, many people have tried to do this. Mythbuster tried to do this. Cody's Labs tried to do this.
Oh, Mythbusters.
Yeah, and the problem is...
you can actually do this. I forgot about vacuums. Put yourself in a vacuum and do it.
Yeah, every time they do this, we watched all these examples. Every time they do this, every time, the exhaust from the rocket repressurizes the chamber, and you don't get movement until you have pressure.
What do you want me to do? Build this now?
No, I don't want you to do anything. Like, I am not asking you to do anything. I'm just answering your questions. Like, if anything, I just want you to be critical of your own beliefs. Like, I don't care if you never turn into a flat earther. Like, you might realize that, well, they're not telling me the truth about the globe. Like, there's contradictions here. I don't want to accept that. Like, you might get to that point, and I'm perfectly fine with you even being a completely zealous glober. Like, I don't care what you become. Like, I don't care what you believe. I'm just here to help you if you want it.
Neither does science.
Yeah, and I love science.
Me too.
So how high has the highest rocket gone, just out of curiosity?
Well, the claim is it's gone to the moon.
All right.
That's
and
the highest.
What's your opinion?
Well, I don't have an opinion on that because I don't know. I don't have opinions on things I don't know.
So we don't know how high the highest rocket has gone. That's very convenient that we don't know how high they've gone.
Yeah, right.
Well, like I told you, I know how high they claimed it has gone. However, I don't actually know. There's a difference between belief and knowing. So I could believe that what they're telling me about how high they've gone with a rocket, or I could just be like, well, I don't know how high they've gone with a rocket. They've told me this high.
Why don't you believe them? Don't you have a reason to not believe them?
I don't have any reason to believe that.
How would you believe that? In what world? Like, what would you have to be there on the rocket?
Like I told you earlier, there's no reason to believe they've ever shot a rocket all the way to the moon. Because according to Werner von Braun and Elon Musk, Werner von Braun said they would need 3 of the rockets that they used to get to the moon, 1 to get into low Earth orbit, and 2 to ferry the fuel to refuel that first rocket so it could get to the moon. Elon Musk said he would need 15 starships just to refuel the spacecraft to get to the moon. So logistically, they never could have gone to the moon. But then we take all of the supposed images and evidence that they've gone to the moon, and we look at the different perspective of the images, let me find the link. I'll find the link for you. This is a...
You said that it takes 1 rocket to get into low Earth orbit?
Yeah, essentially. It uses about 98%, 95% of the fuel to get to low Earth orbit.
And how high is that?
It's claimed to be about... how high is the ISS? Fuck, I need to look that up.
120 miles?
Yeah, roughly.
See, that's interesting because of like maybe 2 hours ago, that's how long I've been here. I don't know if it was you, but people told me that you can't go that high. No one's ever been above 60 miles.
Nobody's saying they went that high. This is what is alleged.
Yeah, the NASA crew and the ISS crew claim to have gone higher than that, but no commercial flight has gone higher than 60 miles, and that's Bezos and crew.
Flight? You mean like in an airplane or any?
No, like Bezos had his penis rocket. He shot Lady Gaga up there and William Shatner, and then William Shatner was like, well, it looks flat from that height. And then the old lady who was like, I'm super disappointed that I couldn't see the Earth curve.
Okay, so how high did they go? Or you don't believe them? You don't know?
I'll give you Neil deGrasse Tyson talking about that just a second.
Very serious scholarly discussion going on here.
Yeah.
Yeah, until you entered into it for itself.
Right. So we just don't believe anyone who says they've gone high. Not hot air balloon, not Bezos, not NASA.
Bro, it's not about, like, what you don't believe them. Like, William Shatner and the lady who went on the flight said the Earth looked flat from that height. However, like, Lady Gaga says something different, but, like, she's crazy. And here's hostile witness, Neil deGrasse Tyson, on Bezos going up.
Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Oh, yeah, so right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody has seen the curvature of the Earth from that height. I just want to make that clear.